All right, hello. This is a video lesson for Unit 1, Lesson 4, which is multiple representations. In this lesson, we will be learning how to write out a mathematical or model a mathematical relationship in several different forms. For this first example, you're going to see a table, a graph, and an equation that we are going to model for the same relationship. If you read the problem, it talks about water coming into contact with heated underground rocks and the temperature based on the depth. So that just gives you a little context for this problem. The information given to us is given to us in this table. And you can see there's a lot of ordered pairs given at the depth of 1 kilometer. We have a temperature of 55 degrees Celsius. 2 kilometers, 90 degrees Celsius, etc. There is some missing information that we're going to try to figure out, and we're going to use the other representations to do that. So the first thing we're going to do is we're going to start transferring this table over into a graph. So I'm going to go to this ordered pair 1, 55 and try to graph that over here. So 1, if we look, the depth is the x-axis and the temperature is the y-axis. So I'm going to look for 1 on the x-axis, which is going to happen right here, and I'm going to look for 55 on the y-axis, which is right here. It's right in between 50 and 60. So we're going to put that point right here, just above 50 on the y-axis. So that's our first point. I just moved 155 over there. I'll color code for a little bit so you can see it. Next, I'm going to do 2, 90. So I'm going to go to 2 on the x-axis, which is right here, and 90 on the y-axis, which is right here, and I'm going to plot that point. Now I'm going to go to 3, 125. 3 on the x-axis is right here. 125 is right in the middle, right here. 125 was right there on the y-axis. And you might notice at this point that we're starting to form a line, and that's important. Okay. Lastly, we have 10 and 370. And I'm going to plot that point right. Here's 10, 370 is right here, so 10, 370 is, right about here. Okay, now depth in kilometers, it is something that we're going to learn later. It's called continuous. There's all sorts of depths between 1 and 2. Those are just some data points we have. So we can actually connect this with a line. So I'm going to draw a line, and on Notability, if you hold this down, it makes a straight line. I'm going to hold this down and go through those points. It's going to give us some predictions about how this graph is changing and what that's going to allow us to see in our table and our equation. Okay? Now, because it's a line, it's changing at a consistent rate, and I think you might be able to see that. Every time we're moving up by 1 with our depth, we're moving up by 35 with our temperature. You could do that by doing 90 minus 55, or some of you might be able to do it in your head. Okay? So you see that every time. This goes up by 35, this goes up by 35. Oh, no it doesn't. So now we have to think, how many 35s is it going up by? Well, this is going up by 70, which means that this 3 over here must be going up by 2 to get to 5. That might be a little bit confusing for you, but we're just kind of piecing together. If I go up by 35 over here, and that means I go up by 1 over here, if I go up by 2 35s, because I'm going up by 70, then I must be going up by 2 over here. Okay, and that allows us to go get another one of our depths. Now, in addition to that, so I've got a whole lot of junk going on over there. Let me clean this up so you can see what needs to be on the table at this point. Okay, we filled in that 5. What's missing on our table? We're missing the temperature that goes with a depth of 0. Well, if going up by 1 over here made us go up by 35 in the temperature column, then going down by 1 would make us go down by 35. So if I take 55 minus 35, I get 20 here. Now, if I'm going up by 3 over here, that means I'm going up by 3 35s. So I'm going to go to my calculator and do 3 times 35 and see that that equals 105. So if I'm going up by 3 over here, I'm going up by 105 over here. And 195 plus 105 gives us 300. We can get rid of all this. And now our table's filled in. Now, the third representation, and some of you might like this third representation the most, and you might actually go from the graph straight to the third representation, the equation, and then use the equation to fill out the table. It's all up to you on what you want to do. But the third representation is we're looking for an equation. When writing an equation, we want, well, and it's an equation for a line. We want start and change values. We want to know how it starts and how it changes. Well, starting happens when you're at your what's called a y-intercept, or at the very beginning. So when our depth, in this case, is 0, that's where we're starting. And we're starting with a temperature of 20. So I'm going to put that down here. We're starting with a temperature of 20. How are we changing? Okay, well, we're changing by whatever amount we go up by in the y-axis, or in this case, temperature, every time. So if we're going up 1 here, we're going up 35 here. We talked about that earlier. That is how much you're changing. We went up by 35 every time. So that's our start and change amounts. Now, we're going to write an equation here with our y equal to something with the x. What I like to just write this as is start plus change. Okay? So I'm going to take my starting amount 20 plus my change amount 35. But we're changing 1, or in this case 35, per every x. So if x is 1, you're increasing by 135. If x is 2, you're increasing by 2 35s, 3 35s, etc. So in that case, we need to multiply 35 by x, so that every time x goes up 1, we'll go up by 35. This is y equals, and I'm just going to put a little note below it so you can kind of see what we're doing. This is y equals start plus change times x. That's a formula that we will use when we're writing equations here at the beginning of the class. So this is our equation, this is our table, and this is our graph. And they all represent the same relationship. And you can actually plug some x's in over here and see what y's you get back. If we plug x in to 20 plus 35x, 20 plus 35 times 5, my calculator tells me that that's 195, which is exactly what we would expect. 5 in for x, 195 back for y. That's the end of number 1. Now we're going to slide into number 2. If you're feeling comfortable, you might want to move on. If you're not, you might want to keep watching the video here. Okay? So, verbal description. This time we have no numbers in our table. And I really don't use this process column here. Okay? It's more for work than anything. We have our graph over here. And we have our algebraic symbolic, which is basically like the expression or equation that we're going to use. Okay? So the verbal description. A moving company charges a $100 flat fee. That means no matter what, you're spending $100. Or another way to say that is at the start, you're spending $100. plus an additional $50 per hour. So that depends on how many hours you're working. The more you work, the more $50 that you earn. Okay, or sorry, the more that the company works, the more $50 they earn. Okay, so I'm going to start with the equation. I really like to do that. So I'm going to go with y equals start plus change times x. Well, the starting amount in this problem is that we're starting with that $100 flat rate. No matter what we're charging, if we're the moving company, we're charging $100. The changing amount is $50 per hour worked. So $50 times x. That means if you work no hours, you get no $50. If you work 1 hour, you get one set of $50. If you work 2 hours, you get the two 50s and, of course, the $100 flat rate, and so on and so forth. And this is our equation. I like that one because it helps us to make the other table and all that, but there's no rules about which one of these you have to do first. I like to start with the equation, but that's just me. Okay, now over here in my table, I'm going to put hours. It's my x, so I'm going to put it first. And then I'm going to put money, or cost, over in the second column. And we're going to try to generate some points here. So the first point that I'm going to put in there is what if they don't work at all? What if they work no hours? Well, no matter what, you charge, or they're charging you $100. So I know it's kind of unrealistic to think they're not going to do any work, but this is really the starting point of our graph. 0 hours worked, $100 earned. Okay? Now, when we start getting more realistic is if they work 1 hour. Well, they have that $100 plus $50 more for that 1 hour they worked, which puts us at $150. If they work 2 hours, they're going to get one more set of $50, so they're going to be up to $200. If they work 3 hours, they're going to have three 50s, so 150, 3 times 50, plus the 100, so 250. And you notice that every time this is going up by 50. Every single time it's going up by 50. 4 hours would get them $300. So I don't have a whole lot of space here on this graph that we made. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So I'm going to go by 50. So 50, 100, 150, 200, 250, 300. And this is my y-axis, which is cost, money. And then over here, I have hours on the x-axis. And there, I'm going to space it out a lot so I have some room. So 0, 1 hours, 2 hours, 3 hours. I almost ran out of room here. 4 hours over here. Okay? So at 0, we're going to plot this point now. 0, 100. So at 0, we put a 100. At 1, we put a 150. At 2, we put a 200, and you should notice a straight line forming through those points. Now I have all 4 representations. Like I said, we don't really need this process column unless you want to show work there for whatever reason. Now we have all the different representations of this particular situation, and we can use that to answer a question. They say determine the charge for a move that takes 8 hours. Well, my table doesn't answer that because 8 isn't on here. I don't know. My graph doesn't answer it because my graph ends at 4 as well. But my equation could do it. If I plug in 8 hours, hours is our x variable, while cost is our y variable. So 8 hours means that x equals 8. So we're going to take this equation and dump it in. Y equals 100 plus 50. We were doing x, but because x is 8, we're just going to plug in 8. And we're going to see what y goes with that. That is y equals, if I type that all into my calculator, 100 plus 50 times 8, I get an answer of 500. So y equals $500. That's how much it's going to cost us to move. $500. Determine how many hours of moving would result in a charge of $450. Okay, again, now this one we could do it in a variety of ways. We could extend our table a little bit. We could extend our graph a little bit. We could try to figure it out, or we could use the equation. It's really up to you. I know a lot of people like to do guess and check with the equation. But if you could figure this out in another way, that's totally fine with me. I'm going to write my equation, y equals 100 plus 50, and it's x, but I'm going to leave that blank. And we know what y is. We're saying y is supposed to be 450 in this example. We're trying to figure out what x makes that happen. So I'm going to say 450 equals 100 plus 50, and I don't know what. And I'm just going to do guess and check. I'm going to do 100 plus 50 times 6. And my calculator says 400. So that's not quite it. But I only need 50 more from that 400, so let's try 7. I'm just guessing checking. 100 plus 50 times 7. And I get 450. So I just guessed and checked until I got the number that worked, which happened to be 7, so 7 hours. Like I said, there's a lot of ways to do this problem, but you pick the representation that you're most comfortable with, and it seems to give you the answer easiest. Okay? Couple more examples here. The next one, a new club was formed at Glenbard East. The table shows how many members have joined the club since it began. Complete the process column in the table and write an equation to model the relationship between the number of months and the number of members. Okay, again, I'm not too worried about the process column. I more use that from work. I'm more thinking about how this is changing. I'm seeing this change by 1, change by 1, change by 1, change by 1, and I'm seeing this increase by 6, increase by 6, increase by 6. So if we're going up one more time, I think we should go up by 6 one more time. 26 plus 6 is 32, and I think there should be 32 members after 4 months. They ask us to write an equation for the number of members, y, in terms of the number of months. So we're right back to y equals start plus change times x, that formula that's really important today. Okay, so start, how much did we start with? We're going to look at the beginning. At 0 months, so at the very beginning, we have 8 members. That's our starting amount. Y equals 8 plus our changing amount is this consistent amount we're increasing by, which is always 6. We go up by 6 every month, 6x. I'm going to move that out of the way. And that's our answer to part B. Then they ask us an interesting question. They say how many members will there be after 9 months? Well, months is our x, members is our y. I'm just going to take that number, 9 months, which is our x, and I'm just going to plug it in to this equation. So we're going to have y equals 8 plus 6 times 9, which is y equals 8 plus 54, which is y equals 62. And we should label that. It's 62 members. And that's the end of number 3. Number 4, they say the homecoming dance committee purchases 1,500 bottles of water for the dance. Each year during the dance, 300 bottles of, let me move this so I can actually see what that question is saying. Each hour, during the dance, 300 bottles of water are consumed. So we start with 1,500 bottles of water, and 300 bottles of water are being consumed, which means we're actually going down by 300 every month. So again, they ask us to write an equation here, and my equation this time is going to be subtraction. I know I've said y equals start plus change x. Well, sometimes the change can be negative, meaning that we're going to actually subtract instead of adding. So in this case, we're going to have y equals the starting amount, which was the 1,500 bottles of water that we start with. And instead of going up, we're going down, so we're going to subtract 300 bottles per hour. What variable did they give us? X, 300x. And that's our equation. They say how many hours, after how many hours will the water run out? And what they're really saying there is when will y equal 0? So they're saying 0 equals 1,500 minus 300x. And again, I would guess and check this. Just plug in some x's until you get the one that's right. And in this case, that's going to happen when x equals 5 hours. After 5 hours, they're going to be out of water bottles. Okay? Now, finally, they're giving us one more problem, and they're just giving us an equation. And they're asking us to say which of these things would make sense with this equation. Well, the thing attached to the x, that's our change amount. And the thing outside is the start amount. I know we've been writing it as start plus change, but it can also be written as change plus start. A little bit different. Okay? Sandy charges $2 an hour. That means we're changing by 2. Parents are charged 5 if they arrive home later than scheduled. Assuming parents arrive late, how much money does she earn for X hours? Well, she's getting that 5 because we're assuming the parents arrive late. So she's getting that 5 no matter what. That's a starting amount, and the change is $2. That matches this equation. So I'm going to circle this problem. It makes sense. We start with 5 and we change by 2. Second one, Sneak Preview is a members-only video rental store. There's a $2 initiation fee. That means you're paying that $2 no matter what, and $5 per, this means how we're changing. Well, change being 5 and start being 2, that doesn't match the equation that's given for 5. So this one does not work. And then number 3, Andy is saving, he starts saving with 5, so he starts with 5. And will continue to save $2. So his savings are going up by 2 every week. That's a change of 2. And that's start and change being 5 and 2, the way it's supposed to be. So this one could also be modeled with this initial equation. And that's it for this lesson. Okay? A lot to unpack there, but we'll have a lot of time to do that. Okay? So you should feel comfortable with this, and we will move on with it tomorrow.